Okay, so first of all, we'll start with the definitions from last week's quick quiz. So first of all, we've got convection currents. So remember that these are currents in the magma which make the plates move. So that heat is coming up from inside the core, and then as it rises, it starts to cool, and then it sinks back down and makes these round kind of circuits of heat, hot and cold magma, cool, it's not cold, it's cool magma as it sinks back down and then heats back up again and creates these currents. Oceanic and continental crust. So remember, our oceanic crust is the tectonic crust which sits under the oceans. It's very, very dense and it's right underneath the oceans, all squashed down under the pressure and the weight of all that water above. And then the continental crust, which is this part here, is under land. It's very thick and buoyant, and it doesn't sink down underneath each other. It pushes upwards when we have our collision plate boundaries. Then we have our tectonic plates. Hopefully you got this one. The crust is broken up into these tectonic plates all the way around our planet, like the surface of a cracked egg or some orange peel. We've got these cracks and they fit together like a jigsaw. Then we have our mantle, which is the layer underneath the crust. Remember, this is the thickest layer inside the Earth, and it's full of semi-molten liquid. And this here, semi-molten, means it's not quite liquid. I did just say liquid, but it's not quite liquid. It's liquid in some conditions and solid in others, in that it's a thick, gloopy consistency, a little bit like custard or ketchup. So today we're going to be looking at volcanoes, everyone's favourite aspect of geography. And to start us off, I thought we all want to look at some pictures of volcanoes erupting. So we'll look at this YouTube video. So click the link down here. It's underneath the video. And this is the link here. It's called Volcanoes 101 if you're just searching for it on YouTube, and watch that through and then come back to the lesson. So volcanoes can be in many different shapes and forms. Like you saw in the video, you often get these kind of classic, like this one here, these classic kind of conical shaped, big pointy volcanoes with a big cloud of smoke coming out the top. That's a kind of classic volcano. Again, this one down here is similar, but actually we can get different types of volcanoes as well. We can get some which are cracks in the ground, like this one here, where the lava is able to spill out and it's much freer flowing lava. We get some that have a lot of ash, like that one there and this one here. It's the Icelandic volcano. A lot of ash coming out, which is more of a hazard than the actual lava in those scenarios. So actually we get a lot of different hazards and different volcanic eruptions happening in different places, and we're going to learn a bit more about that today. First thing we're going to do is we're going to do what are they, then we're going to do where are they, what different types of volcanic eruptions are there, and then what is an example, and you're going to choose an example to research a bit more about. So what actually is a volcano? Write this definition down. It's an opening or vent in the Earth's surface through which molten material erupts and solidifies as lava. So this picture is showing you a volcanic vent. So the vent is the area or the opening where the lava is able to come out. Now a volcano doesn't always have to be pointy, it doesn't have to look like a mountain. They often do, but they don't always have to look like that kind of mountain shape. Some of the examples we saw on the slide before, they have those like cracks in the ground with the lava coming out, and that is equally a volcano. It's just a different type of volcano and erupts in a slightly different way. So pause while you write that down and then come back to the lesson. Okay, so the second thing we want to do is where are they? So you'll probably see from this is a simplified tectonic plate map, and you can see that there's lots and lots of little volcano shapes, and I want you to think about these. First of all, where are the volcanoes? Around which plates do you find most volcanoes? And then thirdly, which two plate boundaries do volcanoes occur? So which two types of plate boundaries do volcanoes occur on? And you can use your notes from lesson 2 to help you answer that. So pause it now, write an answer to those 3 questions in rough, and then come back and I'll give you some answers. So the first thing hopefully you've noticed is that volcanoes occur on plate boundaries. Ooh, make my pen a bit thinner. On plate boundaries. Okay, that's the first thing we notice. All of these red lines show us the plate boundaries. And secondly, which plate do we find the most volcanoes? That is probably going to be this one over here. So if you see that edge there and this here, when obviously our planet is a sphere, so that matches up. That is the Pacific plate here. It's the Pacific Ocean, and along the edges of the Pacific plate, and that matches up over here, which is also the Pacific Ocean. So along this edge we have the most volcanic eruptions. This is sometimes known as the Ring of Fire, like in Finding Nemo, the Ring of Fire, where all of these volcanoes are, because it makes like a ring on the edge of the Pacific Ocean, both to the east side and the west side. And then our third question, on which two plate boundaries do volcanoes occur? The answer to this one is our destructive plate boundaries, where the plate is pushing down. So hopefully you learnt that last lesson. And it also happens inside our constructive ones, where the plates pull apart and then the magma is able to push up and form lava. So there are two types of volcano that we're going to look at today, and two different types of eruption. Now our classic pointed volcano shown by the first picture here, this is a composite volcano, sometimes called a composite cone volcano, and then this one here is known as a shield volcano because it looks like a shield on its side. And I've got this little sheet on here for you. It's copied and pasted twice. You've got one copy of that sheet, so this section here, which is a storyboard for you to fill in. So we're going to fill that in. So if you've got a copy of that, you can print it out, or you can just draw your own version. Pause the tape now and draw your own version if you haven't got a printer, so that you can draw in and fill the gaps. So we're going to draw the pictures in the little boxes here, 5, 6, 7, 8, and then you can read the information in the storyboard underneath. So firstly, we're going to look at composite volcanoes, and these are the ones which occur on our destructive plate boundaries. So if you're looking at your sheet, you need to be in the destructive plate boundary section, and we're going to look at why these happen here. And then we have shield volcanoes, which happen on our constructive plate boundaries. So I'm going to go through each one, and you can fill out your storyboard. So first, I'm going to look at our destructive plate boundary. So this is formed when a continental plate meets an oceanic plate. So by that we mean we've got our continental plate here, this bit here with our volcano on it right now, that's our continental plate, and then we have our oceanic plate here underneath our ocean. And the two plates are pushing towards one another. And as they push towards one another, this one is going down into the mantle. This here is the mantle. And as you can see, this plate is kind of disappearing down here. And what's happening is that plate is kind of melting into the magma here as it goes in. And this magma pushes upwards. So thus coming out of our volcano like lava. And we often get a lot of smoke and ash and dust coming out here as well, because it's quite an explosive eruption, because those two plates are pushing towards each other. So I'd like you to pause the tape now and complete your storyboard with the correct pictures to match the words about what's going on. You can draw that little diagram, you can use the information up here on the slide to help you. Pause it now and complete your destructive plate boundary section. Okay, now we're going to look at our constructive plate boundary. And what's happening here is we've got two plates moving apart. And often in this example, it's two oceanic plates moving apart. So we've got this one here, which is oceanic, and this one here, which is oceanic. And what's happening is these plates are moving away from each other. So it's the opposite to the last diagram. And as they're moving away, this allows the magma inside the mantle to rise up. You can see these arrows showing that is rising up. And what's happening is it's not coming out at much pressure. So it's probably just going to flow down either side of the volcano. And there's not much pressure because the plates are pulling away from each other. Okay, so there's not that pressure of the plates crashing into each other like there is on the destructive plate boundary margin. So we get quite slow flowing lava, and it creates these kind of gently sloping sides that you can see on the diagram over here on the left, with these lava layers forming gently over the top of each other. Doesn't mean it's not still dangerous, it's obviously incredibly hot, but it's not coming out in an explosive way. So if you could draw your diagrams for your storyboard on this one, pause the tape now and then come back. So as a bit of an extension, I thought some of you might be really interested to learn a bit more about volcanic eruptions and what's happening. So we do get a lot of hazards of different sorts at volcanic eruptions, such as, you've probably heard of some of these, pyroclastic flow is a really famous one, obviously ash clouds. Iceland is a very big example of that one, the Icelandic volcanic eruption. We get volcanic bombs, and we get lava flow obviously coming down. And what's quite interesting is to look at some videos of this happening. So if you've got some spare time and you're going through this lesson quite quickly, have a look at some videos of those 4 things and kind of see what those hazards look like, maybe write some notes explaining what each one is. So our last task today is a bit of research, independent for you. So I want you to research one volcanic eruption event, either in pairs or by yourself, depending on who you've got at home with you, and prepare a fact sheet on that. So I've got a template on the sheet which will help you to structure your case study. So please click the link down below so that you can use that sheet to help structure your case study. On the sheet, there are 3 different things. There's what happened, what were the impacts, and how was it managed. So thinking about what kind of plate boundary was it for the what happened, when was it, who was affected, which country did it happen in, and then what were the impacts. So how were people affected? Think social impacts is all about people and how humans are affected. And then, so that's social is all about humans. Then we have economic, which is all about money. So think about your economic impacts. And then we also have environmental impacts, which is all about nature and the natural environment. So split those impacts into those 3 categories, and then think about how was it managed. So for this one, you can look in the short term, how did they manage it, and then the long term. So what did people do in this environment to help to manage this volcanic eruption which was happening? And you've got 5 examples to choose from, or you can do one of your own, but there's 5 examples on the slide: Iceland, Pinatubo, Mount Etna, Nyiragongo, or Mount St Helens. So you can choose any of those case studies to do. I imagine that will take you about 20 minutes to research and fill in your sheet. Okay, lastly, it wouldn't be a lesson without a quick quiz at the end. So I'd like you to copy this down and fill in the gaps for the quick quiz. All the answers are down here at the bottom for you to choose from, so it's not too tricky, and then I'll give you the answers on the start of the next lesson. Okay, thanks very much for listening, everyone. Let me know if you have done the lesson. Send me a little comment, send me the work you've done so I can see it, and like and subscribe for future videos. Thank you.